Hello, everyone. Good afternoon. I hope you're enjoying the event, and I hope you had your lunch, or some of you are still enjoying the lunch, so please enjoy. This is session NET302. This session is about building hybrid application with AWS Outpost to host critical railway applications. This session is based on experience from the project done together with Swiss Federal Railways, or SBB in short, Schweizerische Bundesbahn. You will hear the abbreviation a lot today. My name is Michał Kołodziej. I'm a senior solutions architect with AWS, and today I have a pleasure to have Mark Hinnen with me. Mark is a systems architect from Swiss Federal Railways, and in the recent 1.5 years was responsible for building the SET platform application with Outpost for the SBB. Mark, later in the session, will share his experience and learning from the project. How is the session structured? It is structured in 2 parts. In the first part, I will give you some overview over use cases, why customers are adopting hybrid solutions, like customers like SBB. What are the use cases? What are the reasons for hybrid solutions? Then give you some introduction into AWS Outpost as a service, how to use AWS Outpost in a resilient way, and how to get the most out of it. And then we will switch. Mark will take over and walk you through the project, tell you about the SBB, tell about the platform itself, how it was built, how SBB approached the aspects like resiliency or developer seamless experience, and then give some takeaways for you to implement in your companies. So, speaking of use cases and why customers are adopting hybrid solutions, this could be split in 2 groups, or grouped in 2 groups. The first group is related to networking. The first and foremost and most important reason on the use case why customers are adopting hybrid solutions is low latency. Customers still have a lot of applications or a peripheral system running in on-premises or databases, and they need to maintain very low latency, low single-digit millisecond latencies to those applications. And the second reason why customers are adopting hybrid solutions is that they have applications that cannot sustain longer connectivity issues. And bringing an application talking to each other together closer sort of alleviates this problem. The second group of the reasons why customers are adopting hybrid use cases is that they want to give their developers, DevOps engineers, the very same feeling of building application in the region and on premises, so that they can use same services, same APIs, same tools, and same automation, so that once the application gets deployed, it doesn't matter whether it's in the region or on premises. Because at some point, the dependencies are gone, and the customers want to lift the applications and put them into the cloud as they were built this way from the get-go. How this application could be built? In today's session, we'll concentrate on one service, the AWS Outpost. For those of you who doesn't know, AWS Outpost is a managed service which brings the AWS infrastructure to your on-premises. It is a managed service, which means it is built, tested, integrated, operated in your data centers by AWS, and once you don't need it, it gets collected by AWS as well. It is built on top of the Nitro system, and the Nitro system is a combination of hardware components and lightweight hypervisor to bring performance and better security. It comes in 2 form factors. The first is the standard 42U rack, which comes with the set of core services from AWS like EC2, EBS, Elastic Kubernetes Service, Elastic Container Service, with standard networking with VPCs and subnets, and also databases like RDS, and many, many more. The other form factor comes in 2 sizes. It's either 1U or 2U server. The selection of services is a bit leaner than with the rack. It comes with EC2, EBS, ECS, and IoT Greengrass. In this session, we'll concentrate on the rack. So you know how, you know why, and you know how. But AWS Outpost is just a tool. It's a service. You can get it, bring it into your data center, and you might think you are done. Not so quite. Not so fast. If you are thinking about building a platform for critical applications like we do in this session and what SBB has done, you need to think about resilience. And this is the standard situation. You get one rack, put it into your data center. And you've probably heard the drill already a lot. Everything fails all the time, so we need to address it. How we can do this? What is better than one outpost? Well, two of them. Get two outpost racks, put them into different data centers, geographically separated from each other, and this way you will be able to stretch your workloads and spread the workloads across geographic locations. And the best way would be that these geographic locations and your data centers do have separate power providers and network providers as well, so that you're sort of mimicking the way how the availability zones in the regions are built. Can we do more? Yes, we can, because you can get more than just one outpost rack and combine them together in one physical location as one virtual appliance. This gives you additional flexibility when it comes to scaling out or scaling in, more flexibility when it comes to capacity management, and also you now are able to stretch your clusters, for example, and put your containers or virtual machines with placement groups or taints and affinity groups across multiple hardware devices. And this way you will elevate your resiliency on the compute platform. Compute is great and good, but if we cannot connect to it, it's not much of a use. So we need to address another aspect of resilience, which is connectivity. Each AWS Outpost rack comes with two top-of-the-rack switches. And these two top-of-the-rack switches should be connected to two different physical switches on your side into your data center. The connectivities are not single links. These are configured like link aggregated groups, LAGs, for better flexibility when it comes to bandwidth and also for resiliency. This physical connection is very important because over this connection, we run two additional virtual LANs. The first one is the VLAN to your on-premise services, which is called the local connectivity. And the second one is the one which connects Outpost to the region. It's called Service Link. By default, it runs over internet and anchors in one of the availability zones in the region. The default solution with internet works, but in order to make your application more resilient, you would want to set like a private connectivity between your on-premise and the region. And this could be done with Direct Connect. This brings you this private connectivity with low latency and better stability for your workloads running on premises, which need to communicate to the region. Now, you might ask, what if? What if this connectivity fails for whatever reason? Roadworks or configuration failures, maintenance, all together. Well, in this particular scenario, Outpost switches to so-called static stability mode, which means everything which has been configured on the Outpost prior to the network failure still keeps running. All containers, all virtual machines are there. You can even SSH to these machines from your on-premise networks because the local connectivity is still up and running. And once the connectivity is regained, Outpost synchronizes with the region so that you regain the full control. How many developers or DevOps engineers are in the room? Some. That's good. Myself, I'm also a developer. And you might ask me, do I need to care about all this? Do I need to care about this low-level networking stuff? And the simple answer is no, you don't. Because with AWS Outpost, you keep using the very same construct, the very same services you have in the region, and the connectivity, the stretching between the region and on-premises just happens naturally. You have your own VPC, which stretches between two locations. And you create your own subnets, and you define where the subnets are located. They could be in the region, one or many availability zones, or they could be also located on the Outpost. All services you see on the slide, you probably know with one single exception. This is the local gateway. Local gateway is a special gateway located on Outpost, and this local gateway allows you to connect workloads running in subnet in your Outpost to on-premises and on-premises to your workloads running on Outpost in a subnet located on Outpost. And over this local gateway, you have two modes how you address your applications. It's by default CoIP or customer-owned IP. This is this is done by network address translation, where the IPs or IP ranges routable from the on-premises are mapped to IPs which are sitting on in a subnet on Outpost. The second option you have is the so-called DVR, or direct VPC routing, which is much more seamless and much more integrated, because the same IP range, CIDR range you have set on your subnet is at the same time routable from on-premises and also from the region within the VPC. That's cool stuff. But once you have your final architecture, you want to create it, and you want to maintain the configuration in a repeatable way. And the good thing here is you can still utilize the very same tools you are already using right now in the region. You can use CloudFormation, you can use CDK, you can use CLI, because all services running on Outpost and in the region are very same. So you just change the configuration, saying this EC2 instance is running not in a subnet in AZ1 in region Frankfurt, but it is running in an AZ which is located in a subnet which is located on the Outpost. And this one view or one configuration over your environment is very beneficial when it comes to resilience, because you at every moment, you know how your application is built, and if you need to change something, it is fully automated. And you want to have exactly the same thing when it comes to operation. And you've heard the drill during this talk. You have the same services you have already in the region. You can utilize the VPC flow logs. You can utilize CloudWatch logs and metrics to have a view or state of your application, how healthy it is. You can use CloudTrail to auditing and tracing any API calls towards the services in the region and on Outpost, and therefore you can build one big dashboard where every environment is located, so that you have one pane of glass and you can see easily how your application or your environment is doing. And if you want to elevate it a little bit more, you can still use CloudWatch Synthetics, which is with canaries, so that you probe your application running on the Outpost. And this way you can quite easily, in a swiftly manner, get information about your application, your systems, how they're doing, and discover faults before your customers do, and create tickets or call. Then, if any of you is working for a big environment, for a big company, or you already have a very big environment within AWS, you are probably already using multi-account. So you are adopting multi-account strategy, and this is exactly like what you can do and utilize still with AWS Outpost. You can keep using your multi-accounts, many accounts. You can use RAM, Resource Access Manager, to share Outpost resources or subnets across multiple accounts. You can still keep using ERM to manage access control to workloads running on Outpost. And if you happen to deploy application across multiple environments, across multiple accounts, across multiple locations, you do this with the same tools, with the pipelines, with the cold start tools like code deploy, code pipeline, or any other open source offerings. But this is all the theory. This is how I see this. But let's have a look how it really looks in the real project. And for this, I'd like to welcome Mark Hinnen on the stage. And Mark will walk us through the project with SBB, tell us more about what you have done, how you've done this, and for those of you who do not know, introduce the SBB a little bit in the beginning.
I will. Thank you, Mike. So, welcome everyone. I'm from Südtiroler Railway, called SBB. That's the big train company in Switzerland. I brought you some figures that you know probably how big it is. The most known is the market, the passenger service. That's about 8,000 trains a day, more than 1 million passengers every day. with 15,000 workforce, so they can see a bit. Another thing is the freight service is about 170,000 tons of freights, but this is only a small thing in Switzerland because we have a lot of international freight services, mostly traveling through Switzerland, north to south, east to west, using as a transit. And all of them are using the same kilometers of rails we have, and it's quite a challenge to pass them on time through. One of the core KPI of SBB is the punctuality, the reliability. And sometimes I get asked, why is SBB so successful? In my point of view, one is investment. It's investment in the infrastructure, it's investment in the systems, but it's also investment in digitalization. The business domain I'm working for is the train path production. You probably don't know what this is. That's more or less the realization of the timetable with everyday problems. We have daily disruptions in SBB. We have about, in Switzerland, more than 1,000 events or disruptions every day. With the disruption, for most of you are train freaks like I am, what is a disruption? That could be a missing train driver because he overslept, or a railroad engine doesn't work anymore, a switch is jammed and cannot be changed, or there's an animal near the tracks and you have to get the police. The success factors here of the business are more survey, faster reactions, and automation of business workflows. Like the example I had before, if you have an animal near the trains, if you can automate that to get the police on track and the people can care about real problems. In our business domain, we started digitalization a long time ago, but about 15 years ago, we realized a nationwide prediction of every train, including all these events I just mentioned. They happened, not the one that will happen in future because we don't know them, but everything that just happened, we include in this nationwide prediction, and we know what happened and which delay do we have and what options do we have. About 13 years ago, we started with automating simple decisions so that people can care about complex problems. And at the same time, we started sending the train driver real-time speed recommendations so they come into less conflicts. And then we started to sending them directly to signal boxes and switches so that it's done directly and instantly and not later on with more workforce or with delay. Right now we're working on the whole shunting. Shunting is also a special word. That's bringing the train in the right position before it starts its journey. And it's a big thing for train companies behind the scenes, and there we are now automating a lot of them. And last but not least, we're working on automating complex decisions. And this is not some future fantasy project that will never reach production. We already have it. We're just increasing the types of decisions more and more. More or less everything here you see is done with self-made applications from SBB itself. And for them, we need a platform. So my talk is about a platform and not application itself. I like to talk with you later on how crucial applications should be designed, but this talk is real about the platform for these solutions. We call this platform Halon. That's a play on word with high availability, low latency, and on-premise. What is important is, since they're all self-made, we had the possibility to make some interfaces, and one of them is they all use Red Hat OpenShift Kubernetes as a runtime platform, and they're all using Solus messaging as a communication in between. So the platform has more or less only this interface between the application, or these two interfaces, that has to fulfill. The project started about 3 years ago with an evaluation. Then 2.5 years ago, we started with a pilot. And 1.5 years ago, we started with the real project and building on the final thing we have. As you can think, the main business requirements I just showed you before is availability and reliability, because if this solution doesn't work anymore, everything stops and no train will go on. And as you see, we are increasing the things that we're automating, so the requirements will increase over time. So we can't just build it with today requirements, we have to build it somehow that we can increase with every future project or future production, that we can fulfill more and more availabilities. Second is performance. This business domain is really number crunching. You can almost compare it to Bitcoin or Gen AI. About latency I will talk later on, and repeatability gets a big point. Since we're sending these things directly to switches on signal boxes, it gets safety relevant, and then you have to fulfill some norms. And with that, you have to be repeatable. You have to be able to reproduce exact something that you had once. You cannot just use latest and all the fancy thing you normally have in clouds. Last but not least, disaster recovery. Often disaster recovery is delegated to the platform. In my point of view, that's completely wrong. Every application should think about itself, how it should be solved. And if it's that, the platform don't have to do any magic. But you still need a platform is high available. So we did a wide evaluation and we came to Outpost. I thought to bring you some pictures. There is also a real Outpost at the hybrid corner in the AWS world, so you can look there. But that is how it looks. Outpost is a fully managed IaaS service. That means AWS is managing your hardware, your network, your low-level things. You don't have to care about it. But you have to care about the availability. It's in your data center. So you have to do it. In the cloud, in the region, you don't have this problem, but it's in. And it's also solving other problems like dependencies, or you can use it as a springboard to the cloud. But if you want to use it as a path to cloud, then you have to use it as a cloud. And last but not least, latency. As Michal said, the Outpost can solve your latency problems. And this is exactly working for us. For example, we have legacy applications. They have latency requirements in between. And if one is moving to your new platform, it's perfect if your new platform can just stand beside the other one on the same data center. You just put it there, and then you don't have any latency problem within that. But you also have other latency requirements. We have external systems, we have databases, we have other systems like signal boxes where we contact to, where latency is getting really relevant. Good. Let's get a little bit more technical. How did we do that? First of all, we built 2 productions. We have 2 productions. They're completely separated with different locations, different data center, different configuration. They have even different maintenance windows. They have different AWS accounts. They have different Kubernetes cluster, everything separated. So we have 2. In point of resilience, these applications, as I explained in the beginning, are using a special messaging in between, and we don't have any magic in the platform itself. So for example, we don't have data replication. There are applications on this platform that use database replication, but the applications are solving itself. We don't have to do it in the platform. So we can have 2 separated platforms with no magic in between. And most applications are just running on them, active, passive, and switch over whenever they need to. Beside that, there are 2 independent ones. We also have 2 non-prod, so we can test everything. Again, sometimes I get asked, why don't you just do stretching? Stretching is cool and solves all your problems. It's not. Most outtakes we have comes from inside an application or a platform. It could be a configuration error, a maintenance error, a brain split, or a data inconsistency between your processes. And stretching doesn't help you there. But of course, we will also do stretching cluster, not one, multiple of course, already separated. But if you do stretching, you have to think about a little bit more, because if you have one component with multiple instances, you have to separate it on multiple servers or availability zones. Because if you don't do that, you're increasing the possibility of failure and not reducing it. And if you stretch, you get problem with collocations and the latency again. When we have a new service or a new version, we just don't install it overnight, cross our fingers and hope everything goes wrong. No, we put beside a new version, just beside the other one and running, and each application decides whenever they have a release, a maintenance window, when they switch over. And then one is moving to the new one, and when the last one is gone, your old version isn't needed anymore and you can tear it down. That's there where infrastructure code really helps you, because if you don't have done anything manual, you can tear down everything and everything will be removed, and you don't have anything left. What a bit special here is capacity management. Since Outpost is in your own capacity management, during that phase, you have to think that might be a peak, and that is a little more complicated than if you do it in the region, because there you have enough capacity. It's very important that you follow the same concept as you do in the region. You don't mix architecture, use cloud architecture. When I sometimes talk to our DC colleagues or network people, the first question was always, which rack is the productive and which one is the non-productive? And that's the wrong way of thinking it. Think of it as a cloud. They're just different availability zones. And since like that, you can separate, for example, production, non-production by accounts. But if you do that, then production and non-production runs on the same hardware. It's same in the cloud, in the region. If you have, for example, a developer instance and then you deploy your production instance, it could be running on the same server. You just don't know. And it's the same here. You just have to thinking everything in a cloud architecture and not as it would be on a host on-premise. Now, project, we had some account principle. First of all, we separate stages by accounts. That means we have account for production, for non-production, for development, for internal tests. Then we have different providers. One is helping us with the messaging, another one is helping us with the Kubernetes, and it's better to separate them by accounts, so we have different accounts for providers. And each account, of course, is separate from each other. Michal already said that a little bit special about the resources. In Outpost, all your resources are in one account, and then you have to share it to the other account that you can use it. It's a little bit tricky, but once you get the hands of it, it's not that difficult. As I said before, we separate everything, so we also separate production accounts. So we have one production account using the one Outpost and the other production of the other. And as I said, we have two providers, so we have 4 production accounts at the end. And of course, a non-production thing you can just stretch, so you minimize the accounts. That's the other principle. Don't create immense accounts, just the one you need. But if you have that many accounts, it's important to have an automatic rollout and you don't do anything manually. As Michal explained before, there is this DVR, and this DVR feature is really cool because this DVR allows you to fully transparent your corporate network into your Outpost. So it's the same IPs, the same network segmentation. You connect somewhere. For example, you connect to an EC2, and it feels the same as you would connect to a legacy server. It's the same thing. And we go even a bit further. We added a transit gateway in the region, and we separated this user data from the service link automations. And then you even can connect to something in the region, and it's all the same. As a developer, you don't feel any difference. And as Michal said, some services are only in the region, some are on Outpost. We have now two. We have, for example, also EKS control plane. We have it in the region, but on the worker nodes under Outpost, same with Kubernetes, OpenShift or Route 53. It doesn't matter. For you as a developer, it feels the same. With monitoring, it's the same. If you're using CloudWatch to collect it everywhere, you don't need 3 tools. You just have one, and everything gets together. And the same is with infrastructure as code. You deploy against an account, and then your worker node or whatever you deploy, your subnets are spawned on your Outpost. Sorry. Let's have a look into infrastructure code and our accounts. We layered our accounts. First of all, we have a security layer with security groups. Then we have a basic layer with subnets and VPCs and the whole routing. Then we have a servicing layer with load balancers and whatever we need. And then we have the middleware layer where this Kubernetes and this messaging is. And on top, there would be the applications. But since we are only the platform here, this is 4 layers. Each of these 4 layers has a separated code repository because we are releasing them separately. On top of that, we have stacks. Stacks is a deployment unit. You probably know it from CloudFormation. And one stack can only be in one layer, but they're complete. They have everything. They have their configuration. They have their code for every account, for every stage. This is complete, all in one stack. This helps us if we have a small change just in one thing, we can deploy only this small change and don't have to release everything and have a big change. As you can think, this gets a lot of stacks. We are now at 16 stacks already and still growing. The next thing is I can only recommend you do infrastructure as a code, not as scripting. This is software development, and do it as a real software development as it would be an application. So we decided to use TypeScript because TypeScript is a good language with good ID integration, with unit testing, with ESLint, with Sonar, with formatting, with ID support. And it's also nice, sometimes you have to write a Lambda for adding some features or getting information you don't have out of the box, and you use just the same language, and everything comes nice together. This TypeScript is compiled by CDK into CloudFormation, and CloudFormation, probably all of you know, that's proven and solid. So the deployment part is very well known, and you don't get into problems there. We also use just one pipeline, one for each use case, all stages. That means if my development goes on non-production good, it should also work in production. When we started our project, some people recommended us to create a big framework. And they said, that will be the solution. I said, no, stop. We want to be agile. We want to do just one feature we need and then another other feature. But we knew that there will be a lot of code. So we had to do a software design, a software architecture that is expandable. Just have to keep that in mind, but don't start with a framework. But yes, of course, it got a lot of code. We wrote Lambda loggers, we wrote a default stack that apply defaults. And since we have multiple stacks, you have to export your things so you can import into the other stack. Or we have a config hierarchy with templates, and we have config validation. We have a lot of test helpers, and so on. And a lot of them things are separated, have different life cycles, so you separate them by Git repos, so you can release them separately. And right now we are already at 13 of them for the pipeline helper, for the test application, for Argo CD, and so on. Let me go a little bit about the CDK constructs. CDK constructs have 3 layers. There are layer 3 construct that could say, create me an EKS with load balancer and everything. It's nice, fancy for fast development, it's cool. There are layer 2 where it can say, create me a VPC with subnets, everything. But if you want to have it as it should be, as you want to be defined, then you have to go down to layer 1. And that's how we done it. We do everything with layer 1, and we create our own layer 2. constructs, but it's done for ourselves. And yes, with Outpost, sometimes you have a special parameter, and then you can only do it by later on. We also had some big challenges. One of them is certainly the missing NLB on Outpost. So for every non-web-based communication, we had to build a load balancer that matches its type. Then secondly, a lot of code. And it was a big challenge for networking and DC teams to think of cloud hardware and how it should be used. And that was quite a challenge in our enterprise. And with Outlook, not everything is as shiny as it should be. I don't know if I'm allowed to say that here, but we found for everything a solution, but sometimes you have to think twice to find it. Last but not least, you need a process to bring everything together. We decided to use a classical release process, where you deploy on an internal stage, we do testing, then we go with non-production, we test again, and then we go with production, of course only one, and weeks later on the second. But since we're doing that on the same hardware, same data center, the same outpost, our testing is quite reliable, and on production we never have a lot of surprises. The second thing here is certainly that we had a lot of discontinuous updates you have to solve, and that was not that easy to make with a classical process. We had to remove manual steps, so we have automated everything. We have defined how only small things can change. And if you think at the beginning, we have regulation, we have accreditation, repeatability, all these things. It was quite a challenge, but if you do it by code with TypeScripting, that helped us enough to make it fully automated. So, I hope you enjoyed. That was a little bit interesting, but wait, just a second. Let me summarize again what you have here. First of all, treat your Outpost really as it would be availability zones. It's not the prod rack and the non-prod server, especially if availability is one of the top requirements as we have. Second is, it's hybrid, so that you can do agile and testing, just run it on the same hardware as you would be in cloud. And do it cloud-like, separated by accounts and not by hardware or whatever, and then you have a secure production. And last but not least, treat your infrastructure as a code, really as a first-class citizen in your code base. Do it with helpers, do it with libraries, with test classes, so that it really gets with good quality. Thank you very much.
Thank you all very much for listening. If you have any questions, there is a stand in the AWS World area where we have a hardware rack stand. There are some specialists from the Hybrid Edge team. We will be there, so if you have any question regarding the project or Outpost or hybrid solution itself, you're very welcome. Thank you very much and enjoy the rest of the summit.